Hello YouTube vintage stereo collectors and restorers. You're looking at this realistic STA-47, and I actually put these. The main filter caps, and it's a split rail power supply. There were 4 2200s, 25 volt, one with a burn mark on it, in this place here. And I found some 4700s that I had that were the same physical size, same spread on the pins, so we would only need to have 2 caps there. And since the rails only operate around 20 volts, they could be 50 volt, they could be 35, they could be 20. I managed to, but that looks better, and it should work good too. Actually, it does work. But I found a little surprise. These were glued down, of course, so I had to heat and rock them, and they were right smack side by side, really tight, so it took a little bit of heating and rocking to get them out. And this one here with the burn mark on the side was right up against a resistor and capacitor, actually kind of pushing it down onto the board. So obviously this resistor with the burn marks on it and this capacitor with the burn marks on it were on the board already when the caps were put in. So it's like in manufacturing, the biggest parts sometimes go last, they sometimes go first. But it pushed them together right under the edge of the cap, causing a bit of a short circuit. What is this capacitor and resistor? This is the noble Zobel circuit. And the Zobel circuit is basically a series capacitor and resistor, in this case a 0.022 and a 12 ohm capacitor resistor. Come on, brain, I'm only on my second coffee here. And they're in series between the speaker output, the speaker load, and ground. And what are they there for? Well, to make it simple, they help control fluctuations in impedance from the voice coil and the network, capacitor network, or in the crossover network you want to call it, in the speakers. And it's sort of a guess on the part of the engineers. They don't know which speaker you're going to run on each channel, like what brand, or whether it's just a single speaker with no no capacitor network, or a horn setup. They don't know. It's an approximation. And the idea is, especially with transistors, to keep the damping factor down. So you don't want, when, for instance, a voice coil moves because it's being pushed by basically what's an electromagnet by the output transistors and the program material, there's sort of an out of phase return voltage. If you're watching on the scope, you would see the signal source, and then just slightly behind it at a much lower amplitude is kind of a shadow. And that's the voice coil itself moving and generating, just with a slight time delay. Some scopes won't pick it up. That's what the Zobel network is there for, to improve speaker damping and control. On a tube amp, it's not a big deal because you basically have a voice coil connected to the tube through an output transformer. So that's not as big an issue. But for instance, this one here, the 2 output transistors are connected directly to the speaker. So you could end up with some stray DC coming through the system because the transistors aren't matched or the speaker rails aren't the same. Zobel network doesn't help with that. But what it does help with is controlling the speaker. Now, what always kills me about stuff like this is, so this was sort of trapped like that. Somehow this was touching the rim. And it heated up and melted sometime, not during the time I owned it, but it still worked. And what's interesting, this was burned open. So the Zobel network wasn't working on one channel. I don't think anybody would notice. With most of the speakers, most of the two-way or three-way speakers out there that have good crossovers, you never notice. But it's one of these weird things you find when you're restoring. I'm just going to show you the back of it. You just kind of go, wait a minute, I have like a burnt part here, but it still worked. So here's what I was working on. Let me just make sure you can see that. Oh yeah, no problem. So the Noble Zobel network was over here, and the filters were here, and you can see you had them paralleled on each here. Of course, now there's only one. Actually, over here, the foil was somewhat damaged when I desoldered, and these are hard to get off when they're glued down like that. I was gentle. I removed the solder. I heated it up, tried an X-Acto knife. This one was slightly damaged, so I actually bridged it with the lead and soldered it at the unused contact to make sure it's strong. This one here, no problem. Just hooked it up there as the original was. So that's where I started with the filters, and it actually works and sounds good, and it has a new Zobel network. Now, you could adjust these values and customize it, of course. Let's see. It's right there. So I actually, although the other channel was okay, I actually replaced it so it would be the same. It would be a mirror image. I'm kind of big on that. When I used to build amplifiers, I was really big on having precisely matching parts mirrored in both channels. So if I change output transistors here with a different brand because I couldn't get these, I will put new ones over here too. Might be imperceptible, the difference. If I change one filter because one's bad, I change the other. Same with other parts of the circuit. You try to keep it as close as possible. Anyway, thanks for watching and listening.